Hi, welcome to Simplifying Data Pipelines with Apache Kafka. This lesson will provide you with an introduction to Apache Kafka. After completing this lesson, you should be able to describe what Kafka is and why it was created, explain the Kafka architecture, describe the main components of Kafka, and list some of the use cases for Kafka. What is Apache Kafka? Well, Apache Kafka is an open source project initially created by LinkedIn that's designed to be a distributed, partitioned, replicated commit log service. It provides the functionality of a messaging system, but with a unique design, which we will investigate in more detail in this lesson. Kafka was designed with a few important characteristics in mind, one being that it's very fast. Think big data here. Kafka can handle hundreds of megabytes of reads and writes per second from a large number of clients. Kafka is designed to be distributed and highly scalable. Kafka has a cluster-centric design which offers strong durability and fault tolerance guarantees. Kafka can also grow elastically and transparently with no downtime. Kafka allows you to partition data streams and spread messages over a cluster of machines, which allows you to have data streams larger than a single machine could handle. Additionally, it allows for clusters of coordinated consumers to consume data from the system. Let's look a little at the history of Kafka. LinkedIn is a business-oriented social networking service that is mainly used for professional networking. The LinkedIn website is a highly trafficked, very active site, and it generates billions of log entries and events that capture its hundreds of millions of members' activities every day. The data that's collected feeds various features of the website, such as the Who's Viewed My Profile section, various machine learning-backed social and content recommendations, such as people you may know, and many other back-end monitoring and reporting platforms, including site health auditing and account fraud detection. As the LinkedIn website grew, the point-to-point data pipelines that connected the various systems together began to look like a tangle of spaghetti. As you can see in the first LinkedIn graphic on this slide, there were lots of data systems: relational OLTP databases, Hadoop, data warehouse systems, a search system, monitoring systems, and much more. Each of these needed data fed reliably to it, and they needed to be able to do so in a geographically distributed environment. Additionally, the company wanted to be able to operate on these data streams in near real time to perform analytics as events happen and not solely after the fact in Hadoop or the data warehouse. So, in 2010, they set out to build a system that would meet these goals, and that led to the birth of Kafka. Looking at the second image on the slide, you can see that Kafka straightened out the spaghetti mess, essentially decoupling the data pipeline. Each of the systems at the top of the diagram could now feed into this centralized pipeline. Each of the systems in the bottom of the diagram here could be fed from it. Adding more systems would become much easier, and current systems could easily tap into additional data streams as necessary with ease. Kafka has a variety of use cases. Let's take a look at some of them. Messaging. One major use case for Kafka is that of messaging. Publish-subscribe messaging allows you to decouple the provider of information from the consumers of that information. The sending application and receiving application do not need to know anything about each other for the information to be sent and received. Kafka works well as a replacement for a more traditional message broker. Its unique design generally allows it to have better throughput, built-in partitioning, replication, and fault tolerance compared to most other messaging systems, which makes it a very good solution for large-scale message processing applications. Website activity tracking. A popular use for Kafka is to utilize it for website activity tracking. When users visit a website, oftentimes a variety of metrics and event data is captured, including page views, searches, what the user clicks on, and more. This data can be captured and published to Kafka, which can handle the massive amount of real-time, high-volume data. These data feeds in Kafka are available for subscription for a range of related use cases, including real-time processing, real-time monitoring, and loading into Hadoop or offline data warehouse systems for offline processing and reporting. Metrics. Kafka can be used for operational monitoring data. This involves aggregating statistics from distributed applications to produce centralized feeds of operational data. Log aggregation. Kafka can be used as a replacement for a log aggregation solution such as Apache Flume. Log aggregation is the process of collecting physical log files off of servers and putting them in a central place, such as HDFS, for processing. Stream processing. Kafka works very well as a component of stream processing systems. Data streams can be fed from Kafka into an application such as IBM Streams, Spark Streaming, or Storm. The data can be processed and enhanced by the streaming application in real time, and then written back to Kafka and/or other systems. There are multiple more use cases for Kafka in addition to the ones I just mentioned.